Okay, so help on that first problem. It's kind of the fundamental problem for the stuff that we do, so it's a good one to ask about. The idea is you have a parabola, and if you don't know what the original graph looks like, that's always a place to start. Know what you're dealing with. You're supposed to find all relative extrema for that particular. If it's a parabola, which it is, that x squared gives it away, there's only going to be a minimum, a relative minimum. And so the way we find it is I put a dot on that minimum there. I'm looking for that. And the way we find it is we deal with this idea that the slope of the tangent line at a minimum is definitely 0. It's flat. And the way we can find the slope of a tangent line is through this magical formula, the derivative. The derivative gives us an equation that gives us the slope anywhere on a curve. And if I'm interested in specifically where on that curve the slope is 0, I can just set the derivative equal to 0. So this is kind of the fundamental piece of first derivative calculus, is that f prime of x tells us the slope of a tangent line on f of x for any x. And if I know what that slope's going to be, 0, I can set my derivative, f prime of x, equal to 0, and find the x that corresponds with that. So derivative in this case is 2x plus 6, and that's our magical equation. The slope of the tangent line is 0 at a valley, so we're going to take this 2x plus 6, set it equal to 0. And from there, should be a quick solve, right? You add, subtract 6, divide by 2, you get negative 3. That tells you the x value of that minimum. But the question is, give me the coordinate point of that minimum. And this, remember, this is all about the original function f of x, that parabola. So that's what we're dealing with all the time, is thinking about that f of x function. So let me keep rolling here. If I go to the f of x function, not the derivative, not any other function, just the original, and put negative 3 back in it, so I put a little negative in there. Then we get out a value of, if I multiply this all out, so it'd be negative 3 squared is 9, positive 9. Negative 6, or negative 3 times 6, negative 18. Add 16, and that sum, calculator by hand, is 7. So that means our minimum happens at x equals negative 3, but y is 7. The point negative 3, 7 is where that minimum occurs. So this is the big to-do. We take a derivative and use it as a tool to find out where a min or a max happens. You just set the derivative equal to 0 and solve for x, and that x is going to tell you where those min or maxes occur. To get the actual coordinate point, you have to put it back in the original function to get that location of that point. There is no relative maximum on this, so on number 1, the relative maximum section, you'd write capital DNE, and that would suffice.